All right, let's talk about one of the trickiest parts of chemistry, predicting what actually happens during electrolysis, especially in a water-based solution. It can feel like you're trying to solve a total puzzle in the dark. If you've ever stared at a question like that and just felt completely stuck, then you are in exactly the right place. We're gonna crack this code together.
Does this feel familiar? You're in an exam, you see a question about the electrolysis of, say, brine or a copper sulfate solution, and you're just not 100% sure what's going to show up at the cathode and what's going to form at the anode. That moment of doubt, it's super common.
And listen, it is not just you. Official reports from chief examiners point this out year after year. It's a topic that consistently trips students up. So if you found this tough, you are definitely in good company.
But here's the secret, and it's a big one. The problem isn't that you need to memorize more and more rules. The real issue is the approach. It's time for a whole new strategy. We're going to stop trying to just remember facts, and instead, we're going to start actively deciding what happens using logic. So to do that, I want you to completely reframe how you see this. From now on, I want you to think of electrolysis as an ion race. Yeah, that's right. At each electrode, there's a competition going on, and your new job is to be the judge. Because that's all preferential discharge really is. It's a race between all the different ions floating around in the solution. They're all competing to get to an electrode and either gain or lose electrons. Your job is simply to know the rules of the race and declare a winner. Simple as that. And every single time you do this, your decision is going to follow these 3 simple steps. First, you've got to identify who's even in the race. Second, you apply the rules of the race. We'll call these our 3 key factors. And third, you declare the winning ion and predict the product. It really is that straightforward. So let's get you set up with your official judging toolkit. These 3 factors are literally all you need to make the right call every single time. Okay, factor 1, this is the big one, the most important rule of the race, the electrochemical series. Just think of this as natural talent. An ion that's lower down in the series requires less energy to be discharged, so it's always the favorite to win. This is your default winner right out of the gate. But like any good race, there are twists, and here's our first one, concentration. Now, in a dilute solution, the electrochemical series is king. It's the deciding factor. But if you have a concentrated solution, an ion with a huge presence, like a halide ion, gets this massive boost. I like to call it a hometown advantage. It can actually give it the edge it needs to win, even if it wasn't the favorite to start with. And the final factor is a potential game changer, the electrode itself. Now, if the electrode is inert, think platinum or graphite, it just sits there, providing a surface for the race. But if it's an active electrode, like copper, that electrode can actually dissolve and jump into the race itself. It completely changes who's competing.
Okay, theory's great, but we have our toolkit, so let's put it into action. We're going to use a classic must-know exam question. The electrolysis of concentrated aqueous sodium chloride, brine.
So here's our arena. We've got our 2 inert electrodes, and they're dipped into our electrolyte, which is a concentrated solution of sodium chloride dissolved in water. And this brings us right to step 1, identifying the competitors. Now, because this is an aqueous solution, that's the key word, we don't just have the ions from the salt, the Na+ and Cl-. Nope, we also have H+ and OH- ions from the water itself. And that means we actually have 2 separate races to judge, one at the negative cathode and a completely different one at the positive anode.
Okay, this is where it all comes together. Let's see how someone just trying to memorize rules gets this wrong, and how you, as a decision maker, are going to nail it. The memorizer might just look at the salt, NaCl, and think, oh, sodium is in the salt, so sodium must be what's produced. This is such a common mistake, and it completely ignores the actual race that's happening in that beaker. But we're not going to do that. Let's apply our logic. At the negative cathode, who are the competitors? The positive ions, Na+ and H+. We check factor 1, the electrochemical series, and we see that hydrogen is much, much lower than sodium. It's the clear favorite. The other factors don't really come into play here for the cations. So the winner is the hydrogen ion. H+ gets discharged, and what do we see? Hydrogen gas bubbling off. Boom!
Now for the anode. This is where our toolkit really shines. The competitors are the negative ions, chloride and hydroxide. Now, based on factor 1 alone, hydroxide should win, right? It's lower in the series. But, and this is so important, the question says it's a concentrated solution. This is where factor 2, that hometown advantage, kicks right in. The huge concentration of chloride ions gives it the power to overtake hydroxide and win the race. So Cl- ions are discharged and we get chlorine gas. See how that works? It's not guessing, it's not luck. It's a clear, logical process every single time. So let's just quickly recap your new toolkit.
This is it. This is your 3-step plan to ace any aqueous electrolysis question. First, you identify everybody in the race, the ions from the salt and from the water. Second, you judge the race by applying the 3 factors, in order. Start with the series, then check for concentration, then check the electrode. And third, you competently predict the winner and state the correct product.
So the next time you face one of these problems, the choice is yours. Are you going to be a memorizer, hoping you remember the right rule? Or are you going to be a decision maker, because you now have the toolkit to not just find the right answer, but to know with complete confidence why it's the right answer?